স্যার 22 পর্যন্ত শেষ হয়েছে।
Okay, we'll jump. So this is the other class for the A2. We solved up to 22 of the worksheet. I think this is the 22 number question. So we'll start the discussion
Yes,
from
sir.
23. So problem bolo. 23 তে কোনো problem? Anyone? 23.
B তে 23B.
This question is asking us to sketch a graph of kinetic energy over time. As you can see from the distribution versus time graph, okay, let me take these two graphs and it should be easier for us to work with. All right. So this is the distance versus time graph that we are already provided with. Now, what you should remember that distance versus time graph represents, I mean, the differentiation of the this dt graph gives us the vt graph. So over here, this is a cos curve. I'm sorry, this is a cost curve. So if you differentiate cost curve, what do you get? dy dx of cos x করলে কি হয়?
Sin X.
Minus sin x.
Minus sin x. Minus sin x হয় না?
G, sir.
Okay, so why am I asking you this? Because I want you to visualize that if I want to draw the vt graph from this dt graph, this is going to be a minus sine curve. Now that's the first thing I want you to remember. The period is pretty much same, and frequency is also pretty much same, only there will be a shift of the whole crests and the troughs. Now, for the kinetic energy expression, how do we write kinetic energy? Kinetic energy is given by the expression k equals to half mv square, right? Or ek equals to হচ্ছে half mv square. So half is a constant, m is also a constant, because we are asked to draw a sketch graph. So actually the y-axis values are not so important. Basically, we are interested about this factor. This is v squared. Now, as from this graph, we can say that the vt graph is supposed to be a minus sine curve. So the v square versus t graph, which is very much the graph of kinetic energy versus t graph, because v square versus t graph and the kinetic energy versus t graph would have the same shape. Only kinetic energy versus t graph would have half a multiplied with all the y-axis values. So shape-wise, they're basically same. So if this is sine curve, this is supposed to be sine square graph. Now, what I want you to understand that how does sine square graph looks like? If I go for an option, minus sine curve should look like this. So if I square this, what is the shape that we should get? Should I get modulus, or should I get curve all the way?
We should get a curve all the way.
Which one is supposed to be sine square x or sine square theta?
The second one.
This one. This is the second one.
No, the one before. The one below it. Yes, this one.
Third one.
Yeah.
Okay. So this is the part that I want you to understand, that whenever we modulus something, then we have one shape of graph, and whenever we square something, we have a different shape of graph. I believe I discussed this in our theory classes, so you can look it up in some of our earlier lectures, which might be easier for you to. Did I discuss this ever in our theory classes? Anyone?
Yes, you did. With cross curves, you did.
Yeah, that's fine. So beautiful. So that's why we're gonna try to draw this graph, and we have to find out the time periods or the time instances accordingly. Have a look. If you look over here, this is the highest position or the biggest value for x from. I'm sorry. So here our velocity should be 0, and when the dt graph cuts the x-axis, here the velocity should be maximum. So how much should this graph be? This is how many divisions. You don't have to bother about the exact value of the time axis, because you can see that this graph and this graph, they both have the same time axis scale. So you can simply count division number, which in my opinion is a bit easier to do the math, to work with the math. This is 7.5 division. Do you see it from the very left?
Yes.
7.5 division. So if I try to draw my graph over here, let's say I'm gonna try and draw a 0, 0 graph point over here. I'm gonna start from 0, 0 point. And at the 7.5 division level, I should have my maximum kinetic energy. So which I am trying to label up to 10 division. But the choice of 10 division is absolutely random. I mean, I'm gonna try to accommodate my graph from 0 to 10. This is the part that I'm gonna draw. But if you want to draw it up to 12, that's be my guess, no big deal. But what is really important, these peaks should not have different levels, because as per this graph, it is not showing us any damping effect. Does this graph show us any damping effect? Have a look. As oscillation
No.
goes forward, we have the same amplitude, right? So there's no damping effect shown, so no energy is being lost. Hypothetically, that is something we have to represent in the kinetic energy graph as well, which means that the graph should have the same vertical peaks for all of its positions. So if I try to replicate this graph, and then I'm gonna have once again, sorry, let me just label a couple of points over here a bit more clearly so that I can start drawing my own drawing. And at the 15 division, we have 0. Okay, so I have 3 points over here already. So using these 3 points, I'm gonna try to draw my curve. Okay, let's see. I think something like this might work. I believe it might work, but I'm not sure. I'll have to try.
স্যার কোশ্চেন নাম্বারটা কত ছিল যদি এটা?
হ্যাঁ, ঠিক
It's
বলছো।
23.
দেখো তো চলবে না?
Yes, sir.
I believe so. Okay. So just like that, make sure that you keep the periods exactly same. So here this is supposed to be 0, and this is up to, I mean, from the lowest point to the highest point, this should be 7.5 divisions. Then from the highest division to the 0 position, once it should be another 7.5 divisions. So I have time to keep, I'm always trying to make my peak cut over here at 7.5 divisions from the lowest values. So that's what I'm trying to do.
Sorry, can you repeat the part 7.5 divisions can be our internal value? Sorry.
Because here we can see that within 7.5 division, the displacement reduces from maximum to 0, or the VT graph goes from 0 to maximum. So if I wanted to draw the VT graph over here, that VT graph might as well look like this. You would have 0 over here, maximum over here, a বরাবর.
মানে ডিসপ্লেসমেন্ট যেখানে 0 হয়েছে।
Exactly, কারণ ওখানে হচ্ছে তোমার gradient সবচেয়ে বেশি, because this is the cost curve, so you're gonna have a minus sign curve, so you are gonna, your VT graph, sorry, এটা ভুল হয়েছে, এটা হবে না, এটা ভুল হয়েছে, এটা হবে না. So your VT graph should have a maximum over here, and then it should rise up and become 0 over here, and then you should once again when this one becomes cut the x-axis, this is also perfectly 7.5 divisions. Have a look from here to here, so this will also rise up.
স্যার মানে গ্রাফ থেকে কি আমরা দেখে নিব কোন জায়গাটা হচ্ছে লাইক স্টিফার?
Definitely, you have to find out the time period information or the spacing of the crest and the trough from the graph, because this time axis has given as a scaled option. Because it has given as a scale option, we have to draw this graph with the appropriate scale for the x-axis as well. But for y-axis, there is no hard and fast rule. You can make the peaks go rise up or fall down at any value that you are comfortable with, which that's your choice.
So মানে গ্রাফ থেকে স্যার বেসিক্যালি লাইক ডিসপ্লেসমেন্ট টাইম গ্রাফ থেকে আমরা যে পার্টটা সবচেয়ে বেশি স্টিফ ওখানেই আমি ইয়াটা করব, তাই না? ওখানে আমার বিডি গ্রাফে ম্যাক্সিমাম জায়গাটা।
Exactly,
Yeah,
obviously.
yeah. Okay.
Let's just show one which results in the highest kinetic energy as well.
Thank you, sir.
Sure. বুঝে গেছে সবার? Everyone, কোনো question?
No, sir.
All right. So এটা গেল একটা জিনিস। এরপর হচ্ছে কি লাগতো জানো? আচ্ছা, এটা গেল হচ্ছে এই কোশ্চেন। তারপর 24 কোনো প্রবলেম কারো? 24 পার্সেল
24 BC.
এ পারছো?
Yes, sir.
আচ্ছা, এটা একটু আলাপ করি। This question is talking about that we have a ball that is kind of over here moving back and forth. The mass of the ball is 37 gram. Amplitude is 2.8 centimeter and the sample frequency is 3.5 hertz. So it says the total energy of the oscillation is 7 millijoule. That's pretty simple to do, because to find out the total energy, we're gonna find out the maximum kinetic energy, or that can be also written or expressed as half m omega square a square. So এখানে আমরা half to half m দেওয়া আছে, omega you can write as 2 pi f whole squared, and a ও দেওয়া আছে. So you can have all the value available, and then you write all these things in SI unit, and eventually you can find out the answer in millijoule unit. So that's not a big deal. That's possible, that I'm saying. এটা ছিল হচ্ছে এটা। B number বলছে at 2 points in the oscillation of the ball, kinetic energy is equal to the potential energy stored in the springs. Calculate the magnitude of the displacement at which this occurs. So this question is essentially asking us about this specific point. Which point? ওই যে আমাদের গ্রাফ ছিল না? এই যে this question is asking us to find out what is the value of the x over which both of these energies become equal. So questionটা বুঝো সবাই আগে, and একটা জিনিস খেয়াল করো, whenever the potential energy and kinetic energy are equal, you have to understand logically that would essentially mean that the potential energy value or the kinetic energy value, either of them is equal to half of the maximum energy or half of the total energy. Does this idea make sense? At this level of displacement, P equals to half of T, or K equals to also half of T. Do you understand this part? Check this out.
Yes, sir.
এটা হাফ কেন হচ্ছে? হাফ কেন হচ্ছে?
So দুইটা equally distributed.
দুটাতেই equally distributed হচ্ছে. That's essentially what means that that's essentially the significance of the two curves crossing each other. So they have equal values, and the sum of them would make up the total energy amount. So essentially they have to have half of the value because they are equal. এই যে লজিকটুকু মনে রাখলে তুমি পরের কোশ্চেনটা খুব ইজিলি সলভ করতে পারবা। That is the part of the logic that was missing for from your arsenal to be able to solve this thing. The question says calculate the magnitude of the displacement at which this occurs. So displacement calculate করার সবচেয়ে সহজ বুদ্ধি হচ্ছে আমাদের half m omega square a square minus x square. So let's say at that level of where that intersection occurs, the energy of the whole thing is half. Just a second, kids. I need to make my. Every once in a while, my mouse pad becomes more sticky than usual because it's pretty old, and I actually dust it with talcum powder to give it a bit more slippery surface. Can you believe it? I feel like a boxing player. Yeah, now much better. Did you guys ever see the animation where Kobe Bryant, Kobe Bryant now? What is the name of this player who Michael Jordan. Michael Jordan shakes his hand in front of the commentators. Anyone?
sir.
No.
স্যার ওই
Was
যে
it
মানে খেলা
was it
খেলা খেলার আগে যে পাউডার দিয়ে যে হাত
hey,
রাব
was it
করে
Kobe Bryant or Michael Jordan?
না স্যার মাইকেল জর্ডান আর লেব্রন জেমস করে মানে
স্যার ওটা লেব্রন জেমস মাইকেল জর্ডান না স্যার
না স্যার মাইকেল জর্ডানও করে
ইউ মিন করতো
করতো।
yeah
He left. Involved really makes the game very.
He shares a special ritual.
I think it.
Even to the point where Jordan includes him in his pregame ritual.
Got something for him, though.
Oh, there are fans in the stands, and then there are fans right here.
I think it started one time when he put the rosin on his hands, and as he dusted it off, Jim and I sort of complained about. Wow, he's getting that stuff all over.
First, it was just for fun, but now it's more or less a routine.
আচ্ছা পরে দেখাবো না কি বলতেছিলাম Oh, since we have already calculated the total energy of the whole system, for this next question that we are trying to solve, which is this one, that how much force we are managing of the decision at this point. So this is very simple to work with because this would be half of that amount of energy. So half of half m omega square a square, this is the total amount of energy, should be equals to, this one should be equated to the kinetic expression half m omega square root over root over হবে না এখানে হবে হচ্ছে a square minus s square. If you wonder কেন root over হবে না, because we used to give the root over for the velocity calculation, but whenever we go for the energy calculation we have half m v square. So this part essentially takes care of the v square part. So that's why the root over is missing. So there's a reason that I'm writing this equation in this format, because I don't want to do the whole value replacement of this whole things over here. Once again, writing this equation in this format gives you the big advantage that you can get rid of all of these parts immediately. Do you see what I mean? Half m omega square, half m omega square, you don't have to put those values anymore. So you can very easily go away with this. Shubho, তোমার নাম্বারগুলো খেয়াল রাখো. I'll be going through forward. I'll try to keep an eye over here, but if I miss anything, you respond. So এটা এখানে আসলো. So এখান থেকে ultimately আমরা যেটা পাবো সেটা হচ্ছে half a square equals to a square minus x square. Now this is pretty simple to solve because you know the value of a, so you place the value of a and calculate out the value of x. এটা ক্যালকুলেট করে দেখো তো কত আসে বলো
স্যার লেফট হ্যান্ড সাইডের ফর্মুলাটা কিসের ফর্মুলা যেন ভুলে গেছি
এটা হচ্ছে কাইনেটিক এনার্জি ফর্মুলা
আচ্ছা
এই যে half a omega square a square minus x square. আর তুমি যদি এটা লেখো তাহলেও হবে, অথবা হচ্ছে ওটা কি পটেনশিয়াল এনার্জি, অথবা তুমি যদি এখানে শুধু x স্কয়ার লেখো তাও হবে, because both of them would be exactly equal, because ultimately this will give you what? Ultimately this will give you half a square equals to হচ্ছে x square. So if you write,
মানে আমরা লিখছি যে half of total energy equals to kinetic energy.
আমি ওটা লিখছি, yes, but you could also write half of total energy equals to potential energy, তুমি ওটা লিখতে পারতা, সমস্যা নাই.
Okay sir.
Ultimately you would get this value, so it's justifiable. বুঝতে পারছি? এটা ক্যালকুলেট করে দেখো তো কত আসে. Someone help me. Give me a number. Important to observe before you go for the calculation is the answer. What do I mean by that? You have to look at the unit at which the answer is asked, and the answer is asked in centimeter unit. So you better not convert this thing into meters. Use it in centimeter unit. Find out the x in centimeter unit. পারছো এটা আঁকতে? এটা করো, আমি পরের কোশ্চেনটার জন্য আমি ইয়া করতেছি, এই জিনিসটা কপি করে নেই। কত আসছে? সারিতা, তোমার রোল নাম্বার তো শুধু 73 না বাবা। I have given all the roll numbers in 1073 মনে হয়। না 1073 না। সারিতা, তোমার রোল নাম্বার হচ্ছে 1065। সারিতা, শুনতেছ? হ্যালো? আচ্ছা আচ্ছা, হ্যাঁ ঠিক আছে, ওকে, শি ইজ হিয়ার। সো এটা মিলছে? আগেরটা মিলছে? এক্স এর ভ্যালু কত আসছে? এক্স এর ভ্যালু বলো। আমার এক্স এর ভ্যালু লাগবে, এই গ্রাফটা করার জন্য আমার এক্স এর ভ্যালু লাগবে। হোয়াট ইজ এক্স ভ্যালু?
স্যার 2 centimeter.
এক্স্যাক্টলি।
So 1.98 আসে।
1.98 2.0। আচ্ছা ঠিক আছে, 2.2 সেন্টিমিটার, ফাইন, ঠিক আছে। আর হোয়াট ইজ দ্য টোটাল ডিসটেন্স, ম্যাক্সিমাম ডিসটেন্স, অ্যামপ্লিটিউড কত বলছিল? হাউ মাচ ইজ দ্য অ্যামপ্লিটিউড? The amplitude was defined as 2.8 centimeter. So might as well write that because I'm going to need those things as well. What is the total? What is the total value of the total energy? Total energy value, which we did calculate in A. How much was this?
That was 7.0 millijoule.
7.0 millijoule. So I'm going to need that value as well. So I'm going to show you how to draw this graph with specific coordinates for which the examiners are going to judge you upon. The examiners are going to judge you upon whether you did draw the graph up to this much point. So they are expecting a horizontal line from within the range. So what is the range? Amplitude range is 2.8. 2.8 মানে হচ্ছে 2 division from the right, 2 division from the left. So this is plus 2.8, this is minus 2.8. So I might as well draw a horizontal line. So I'm showing the total energy with, let's say, black, 7.0 millijoule. So this is the line from minus 2.8 all the way up to plus 2.8. This should be my total energy line, and you should label this. এটাকে লেবেল করতে হবে কি দিয়ে? T দিয়ে। So label this with T right over here, capital T, or you can give a line over here and label this as T. Either way it works. And then for the kinetic energy graph and the potential energy graph, we have to draw a curve. Now the curves are going to start, potential energy graph curve is going to look like this. Potential energy curve is going to look like this, and kinetic energy graph is going to look like this, which we know the shapes. But important point is that we have to take care of this point as well. We have just calculated that the value where the two of these energies become exactly equal to each other is 2 centimeters. So these graphs might as well start from here and pass through over here, but we would have a intercept exactly over here. So this much was 7 joule. So how many divisions is this? So how many divisions is this? Vertically, how many divisions is this?
So 35.
35 অর্ধেক হচ্ছে
17.5.
17.5. 10, 15, 17.5. So this is the level, and 2 is here. So our curve should pass through this point on the left sides, and over here this point on the right side. So we are gonna have to make our graph pass through this coordinate. This is the what the examiners would mark you upon. So আমি একটা curve ঠিক মতো আঁকতেছি, then I'm gonna copy paste it for my purpose so that I can understand what I'm doing. So have a look, keep your eyes peeled. Let's say I'm gonna draw this part of the curve first. So this is easier for me to work with here. So I'm going to give you some good tangent property over here. So a bit of a tangent behavior, and then I'm going to curve this enough like that. See if you can agree with this point. বুঝা যাচ্ছে কিনা দেখো। I made this graph pass through the 2,315 coordinate, because at 2 centimeter mark we should have the two energies equal. That should be 3.5 millijoule. 3.5 millijoule happens to be over here. This is how your one part of the graph should look like. Now because I want to reuse this thing, just a second, একটু question নিচ্ছি, একটু পরে একটু wait করো। I'm gonna I need to zoom out করলে তো এটা এখন দূর, আমি কি এক্সক্লুসিভলি এটা কপি করতে পারবো?
I think you can, just do Control X to cut it instead.
না, কন্ট্রোল এস করার জন্য এটা আমরা কোথাও প্লেস করতে হবে। হ্যাঁ, এখন হয়েছে। Okay, so I'm gonna need this one, and now I can very easily go ahead for my manipulation. So let's say this much should be over here. I would also need it to horizontally shifted, which would mean flip horizontal. Beautiful. So this is supposed to be my which graph?
Kinetic potential energy.
This is supposed to be my potential energy graph. So you label this with the appropriate number, and then to draw the kinetic energy, you just have to vertically flip it. So I'm taking this over here, rotate, flip vertical, and place it up over here. Okay. Now we are having a bit of a trouble because I did not. Okay. বুঝছি ঝামেলা কোথায় হয়েছে। Never mind. I believe I can take care of it. Might as well make this into a different color, but I cannot do this because I have already drawn the main graph with this value. So this graph is not essentially becoming very perfect, but I want to make sense of what I'm trying to do. This should be passing over this through this 2 point. Okay, this is not becoming very perfect because, but I made it a bit displaced because my drawing is not being very perfect. So what I want you to understand that both of these graphs should cut through these 2 points. Which 2 points? A একটা coordinate which you have to take care about. A একটা coordinate which you have to take care about. And these are the terminal values of the 2 graphs. And essentially, the maximum number is over here, and the 0, 0 point is over here. So you have to take care of this part of the graph. So the additional thing that the examiners might also look like is whether you have made your graph tangent with the x-axis over here. What I mean is that you cannot draw a graph. You cannot draw a graph which looks something like this. Let me, if I draw a line for blue, this line cannot appear to have a non-zero gradient like this. That would be wrong. So this should be a smooth curve, pretty much tangent with the x-axis over here, and over here a tangent with this total energy line. So at this point the curve should have zero gradient. That's the important bit. So you should be careful that you don't have any curve over here. Now you might wonder, drawing a curve like this in a software environment like I'm doing is pretty simple, but how are you going to draw this thing? Well, you have to practice. Important bit is that these gola points, the examiner is going to look for whether you actually conform to the coordinate of the red circle that I have labeled over here, and also in terms of the shape, they're going to look whether you have made it tangent with the at their y-axis intersection locations. হ্যাঁ, আরমান যেটা বলছো সেটা আমরা করতে পারতাম, আমি ওটাও দেখাচ্ছি যে ইভেন্চুয়ালি ওটা করলেও আমাদের আলটিমেট ইকুয়েশনটা সেমই আসতো। ওই হাফ এ স্কোয়ার ইকুয়ালস টু এক্স স্কোয়ার ওটাই আসতো। আমি কাইন্ডলি যদি করছি তুমি পড়াশোনা যদি করতে পারো কোনো সমস্যা নাই, বোথ অফ দেম আর ইকুয়ালি অ্যাকসেপ্টেবল। ইয়েস সাজিদ বলো।
স্যার আপনি ওই যে এক্স অ্যাক্সিসের যে পয়েন্টটা ওটা কিভাবে পেলেন? মানে এক্স
কোনটা?
অ্যাক্সিস এক্স কোঅর্ডিনেট ওই যে আমি বলে
এটা
মানে আপনার ইয়েতে কি বলে ওটাকে কোঅর্ডিনেট অ্যাক্সিসে যে ইন্টারসেক্ট করছে গ্রাফগুলো ওই
এটা
পয়েন্টগুলো, না 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 এটা না এটা না, কোঅর্ডিনেট অ্যাক্সিস মানে ওয়াই অ্যাক্সিস এক্স অ্যাক্সিসে যে
এই
পয়েন্টগুলো
ওয়াই
কাট করছে।
হ্যাঁ
এক্স অ্যাক্সিস এটা বলেন ওই যে হ্যাঁ এই পয়েন্টটা কিভাবে পেলেন?
এই যে আমাদের কোশ্চেন বলে দিছিল তো যে আমাদের the amplitude of the whole oscillation is 2.8 centimeter, so maximum is going to move up 2.8 centimeter on the right side
আচ্ছা আচ্ছা বুঝছি।
and on the left side 2.8 as well.
আচ্ছা, আচ্ছা।
Are we clear with the graph construction of this question? Any question, anyone?
জি স্যার। না স্যার, থ্যাংক ইউ স্যার।
Beautiful, no problem. Anyone? Is it clear to every one of us?
Yes, sir.
So we're going to move on. So 25. Anything from 25? এই কোশ্চেনে কি আমাদের গ্রাফ লেভেল করতে বলছে? হ্যাঁ, এই কোশ্চেনের জন্য গ্রাফ লেভেল করতে হবে। দিস ইজ ভেরি ইম্পর্টেন্ট। আচ্ছা এই গ্রাফটা একটু দেখাই। এখানে আমাদের maximum acceleration of the ball is defined as 5.2 meter per second square, and that maximum acceleration happens at maximum amplitude. Oh wow, thank you. আমিন দেখো তো মামুন আমার একটা পান খাইতে পারে কিনা, জিজ্ঞেস করো তো কাছে হয়ে পাইছে কিনা আজকে। Sorry. So here we found out the maximum amplitude of the whole thing was how much? 1.7. 1.7 centimeter is the amplitude. So this question here we were supposed to prove that the maximum acceleration is supposed to be 5.2 meter per second square. Now this is a problem that we have over here. Have a look. Have a read for the description. Use your answers in A to plot, not sketch. Important word. To plot on the axis of figure 3.3 the variation of this is an x of the variation of the x-axis of the ball, which means on this axis you have to plot, you have to give values on your x-axis coordinate and also on your y-axis to get these numbers. So এখানে আমাদের in this case the maximum distance was, sorry, the amplitude was 1.7, so you might as well prefer to draw up to 1.7. So how many divisions do you have on the right side? Divisions. You have 30 divisions. So if you are trying to represent 1.7 conveniently, you cannot go for a double scale because that would require 34 divisions. So you might as well draw this up to 17 divisions up to here. So you're gonna draw the exact same scale: 1.0, 2.0, 3.0. So already the graph is already covering for the requirement for the centimeter because they have given the 10 to the power minus 2 value. Let me take this out and try and draw and talk about this. Okay, so what I want you to see and understand is that what is the value for our amplitude equals to 1.7 centimeter, and the maximum acceleration was calculated to be how much? 5.2, I believe. Yeah, 5.2 meter per second square. So this was calculated to be 5.2 meter per second squared. Okay, beautiful. So we have to first label these two scales so that we can cover more than half. So over here I'm going to label this as 1.0, 2.0, 3.0, and similarly over here as well, minus 1.0, minus 2.0, and minus 3.0. And then on the y-axis I have to show a maximum value of 5.2. We also have how many divisions over here? 30 divisions. So what could be your preferable scale?
So এখানে তো আবার এন্ড পয়েন্ট মার্ক করতে হবে না?
2 or 6.
হ্যাঁ হ্যাঁ, এন্ড পয়েন্টটা মার্ক করতে হবে। সো ওই জিনিসটা আমি বের করতে যাচ্ছি যে এটা এখানে স্কেল কি চুজ করা যায়?
2, 4.
মানে 2, 4, 6, তাহলে 5.2, হ্যাঁ 2, 4, 6, beautiful. Yes. এখানে অলরেডি আমাদের have a look here, the unit is already mentioned to be 10 meter per second square, so we don't have to bother. You can simply write 2.0, 4.0, and 6.0. But you have to do this scaling over here because of this word. Very important for you to observe, not sketch. Plot. Plot means you need actual coordinates. Sketch means only the shape. So important for you to observe. Here minus 2.0, minus 4.0, and minus 6.0. So 5.2 কোন জায়গায় হবে বাই করো? এখানে হচ্ছে 4, exhibition is 0.2 over here. So এখানে হচ্ছে 5, এখানে হচ্ছে 5.2. So 5.2 should be available at 1.7. 1.7. এই যে এখানে একটা কোঅর্ডিনেট হবে। So one of the coordinates are going to be over here. So I might as well give a bit of a red circle so that you can understand what point I'm talking about. And
what is negative acceleration at this point?
yeah, exactly. So negative displacement is giving you positive acceleration. Always the acceleration versus displacement will always have a negative line. It should be a negative gradient straight line. So I found out one coordinate over here. I can very easily find the other coordinate for 2.0 this amplitude on the positive side. That point should be located at minus 5.2. So this is 5, 5.2 is over here, one division below. Nah, আমি এটা ভুল লিখছি না?
Ji sir. Divisions
এখানে হবে তাই না?
জি।
এক ডিভিশন উপরে হবে।
হুম।
I did a bit of a mistake over here. So this is supposed to be one division above, and here this is 2 and 5.2. So this should be one division below. 2 না তো 1.7. বাবা ভুল করতেছি কেন? 1.7 with 5.2. 5.2 right over here. So this should be my other point. So my other point should be here. So yeah, so these are the two coordinates that you have to work with. So now I can very easily try and complete that drawing by joining this with a straight line, which I cannot do in that zoom value. So simply join a straight line from this point to that other point, which should definitely pass through the origin by all means. So that's how you are supposed to draw this graph. See if it makes sense, everyone.
So এটা কি খালি আমি ওই পয়েন্ট পর্যন্ত যাবো নাকি আরো এক্সটেন্ড করে দেব?
Is the object moving any further other than 1.57 centimeter from the question? Have a look.
Amplitude is
1.7. So you cannot make it go any further. You cannot. Tapor. If we go on further down the line, we have the it's simple. This is the same exact question. Kinetic energy is equal to 1/2 of the maximum kinetic energy. Same question as we saw earlier. 26 is no problem, anyone? 26 A2 Shubha mark also. So might as well look at it. A mass of 78 grams suspended from a fixed point by means of a spring as illustrated figure 3.1. The stationary mass is pulled vertically downwards through a distance of 2.1 centimeter and then released. The mass is observed to perform simple harmonic motion with a period of 0.69 seconds. The mass is released at time t equals to 0. For the oscillations of the mass, calculate the angular frequency omega. Okay, so that's not very difficult. You are given the time period, you're going to calculate the omega. In A2, it says that determine the numerical equation for the variation of time t of the displacement x in centimeter. Okay, how much is our amplitude? 2.1 centimeter. As per the question, it was pulled vertically downwards at the beginning. So if you consider the typical idea for our direction sign, if this object is initially here, this horizontal level should represent zero displacement. As it goes downwards, we should have negative displacement. So this object is gonna start its journey while it is at the lowest point of its motion, as per the question. So this equation that we're going to build up over here should be in cosine, and to be more exact, it should be in minus cosine form because it is starting negatively downwards. Question the question doesn't say specifically that which direction is to be considered positive or negative, but I'm going to write my equation over here as negative because I'm comfortable with that. So what do you think this equation might be? I might as well take this part and try to write this equation. সো এটা কত আসছিল অ্যাঙ্গুলার ফ্রিকোয়েন্সি? এটা কত আসছিল?
Sir, 9.11.
সো আমাদের টিপিক্যাল ডিসপ্লেসমেন্টের ফর্মুলা হচ্ছে in the minus cosine form x equals to minus a cos omega t. That's the formula. So we're gonna try and write this equation using this formula step by step. This is the generic formula that I'm writing to help you remember how this equation is supposed to look like. So x equals to, now I'm writing the answer for that question, which is not over here. X equals to minus, এখানে amplitude কত? 2.1. 2.1 cos 9.11 t centimeter. That's the entire equation that you are expected to write for the question. Which one? This one. And then there you are asking you for the speed v in meter per second. Speed বের করার জন্য simply তোমাকে ওই ডিসপ্লেসমেন্টের ইকুয়েশনটারে ডিফারেন্সিয়েট করা লাগবে। So if you differentiate this equation, how much do you get? বলো তোমরা তো অনেক কিছু পারো। Tell me. If you differentiate this equation, what should you get? cos কে ডিফারেন্সিয়েট করলে কি হয়? মাইনাস সাইন হয়। So this should be written as v equals to dx by dt. dx by dt না লিখলেও সমস্যা নাই, but it's good if you write this, then the examiner would know that you really know your shit. So now you differentiate this. If you differentiate the cosine ratio, you get a minus sign, and you did give a default minus sign over here. So this would become altogether positive. So, and you have to multiply 9.11 into 2.1. How much do you get for the maximum speed? Give me the multiplication value. Two point one into 9.11.
Sir, 19.1.
So this should be 19.1 sine 9.11 t centimeter per second. That is the expression altogether. দেখা বুঝা যাচ্ছে কিনা? শুভ্র বুঝা গেছে? Yes or no? I believe you say yes. Okay, I'm gonna go for 27. Should I go for 27? 27 কার problem আছে? Anyone?
Yes, sir.
27. আচ্ছা, question 27 একটু খেয়াল করি, পর্যন্ত পড়ে যাচ্ছি আমি। The question 27A says define simple harmonic motion, and then it says a simple horizontal plate is vibrating vertically, as shown in figure 2.1. Vertical oscillations have a frequency of 4.5 hertz. Cube has a mass of 5.8 gram, as shown in the figure. The plate undergoes simple harmonic motion with a frequency of 4.5 hertz and the amplitude of 3.00 millimeter. A metal cube of mass 5.8 gram rests on the plate. So, okay, so we have this whole expression. Now, the plate undergoes simple harmonic motion with a frequency of 4.5 hertz and an amplitude of 3.0 millimeter. A metal cube of mass 5.8 gram rests on the plate. Okay. That's okay. Calculate for the cube the energy of the oscillation. Energy of oscillation is the total energy of the oscillation.
C1 C2 তে প্রবলেম ছিল, এগুলো পেরেছি।
কোনটাতে?
C1 C2
আচ্ছা। C there was the amplitude of oscillation of the plate in B is gradually increased. The frequency remains constant. At one particular amplitude, the cube just loses contact momentarily with the plate. State the position of the plate in this oscillation at the point when the cube loses contact. I'll help you to understand this thing. What is the first thing that you need to understand? That as the plate will be going up and down, it is going to be accelerated because of its motion. Now, to make sense of what I'm saying, I'm going to use this figure. So I might as well copy this. let me take out this part for my discussion. Okay. So let's say this is our equilibrium position. Let's assume that this is our equilibrium level. Okay. So we're gonna start to make this thing move up and down. So let's say on the highest part, when the contact is lost momentarily, let's say the highest point of the motion was here, and let's say the lowest point of the motion is supposed to be over here, because we are supposed to have equal amplitudes on both sides. So try to understand, as per the definition of simple harmonic motion, when the particle is over here, we have zero acceleration. Only I'm talking about only for the SHM. I'm gonna come to the idea of weight after a while. So for the time being, just consider it for the SHM. As the particle goes downwards, the acceleration works upwards. As the particle goes upwards, the acceleration works downwards. Do you understand?
Yes, sir.
Now, this is the key information that you have to understand, that we are gonna move hold up, I need to think the working of this problem. I can explain this, but I'm trying to think of an efficient wording. So before I just go ahead for the explanation, at which point do you think, from your basic idea of moving stuffs, maybe in on the palm of your hand, if the object is supposed to lose contact with the plate at one point of its motion, where that location might be? Which one do you think?
Sir, upwards.
Highest position of the motion, right?
Yes, sir.
From our experience, it says that at the highest position of the motion.
Sir, highest এর চাইতেও আরেকটু highest হবে না?
Highest এর যেতে highest আমরা মুভই করব না, highest মানে হচ্ছে maximum movement. Once you define something to be highest,
মানে
it
স্যার
will have-
অরিজিনাল
What she meant was that যে inertia কারণে কি ওই ব্লকটা আরো একটু মুভ করবে কিনা?
No.
স্যার আমি বলতে চাচ্ছিলাম যে নরমাল অ্যামপ্লিটিউড যে অসিলেশনটা, সেটার কোনো কারণে যদি আপওয়ার্ডস অ্যামপ্লিটিউড বেড়ে যায় তখন ছিটকে পড়বে না?
Well, the object is gonna the idea is that if we continuously keep on increasing the amplitude of the motion, so we're keeping the frequency same, we're slowly increasing the amplitude, so the acceleration will also become higher, because as per the formula, we have the maximum acceleration is given by the formula a max equals to minus omega square a, ঠিক না? So if a is slowly gradually increased, as per the question said for the earlier part, a max is also gonna become bigger. You're gonna have the contact lost momentarily, exclusively or exactly at the point where the acceleration would become equal to the gravitational acceleration, which means when the object will use all of its available gravitational acceleration to maintain its simple harmonic motion, then it would have no acceleration left to push onto the plate. Like I've used the same idea in earlier cases as well for the case of circular motion, that when part of the gravitational force was used to maintain centripetal force, then we human beings who are present on the Earth's surface, we could not exert all of our weight onto the Earth's surface. We could exert a smaller portion of the weight onto the Earth's surface, because a small portion was used up to maintain our circular motion. Do you remember that part?
Yes, sir.
So over here, for each position of this block, it has its available weight. Weight has a fixed value, and gravitational acceleration also has a fixed value. So if at any point of its motion, the object has to use all of its gravitational acceleration to maintain the SHM. If you wonder why it has to maintain the SHM, because you need to understand that the particle is experiencing weight because of its own virtue of gravitational force, which is mass, and at the same time, it is undergoing SHM. So the actual motion which is happening for this particle is practically the SHM, simple harmonic motion. So the particle is going to use its own, available acceleration to maintain that SHM, pretty much like circular motion. So for a specific value of A, this acceleration downwards would become equal to 9.81, or let me just write symbol G. When this will happen, then the particle would not exert any force onto the plate anymore. That is the instance where the block would slightly or for momentarily lose contact with the ground. Now you might wonder that losing contact means actually going upwards. So we are talking about transition level. Transition level মানে হচ্ছে, try to think of it. If you consider the number line here, let's say here is 0, and let's say here is -1, and here is the -2, here is +1. So at which position, so if we slowly start to increase the number from -1 to +1, at which position does the number become positive? Let's say আমরা একটা ভ্যালুকে আস্তে আস্তে বাড়াচ্ছি. At which position does the number become 0? Now the idea is that when the number flips from minus to 1, or you can say in logical sense, when the number value crosses the 0 line, then it becomes positive. 0 is basically the borderline of the negative region and the positive region. So 0 value, it doesn't essentially have any thickness. You have to understand this part very easily. The 0 is a specific number. On the left of it, we have negative region. On the right of it, we have positive region. So this is very thin, sharp line, which doesn't have any thickness. If you wonder why am I talking about thickness, because whenever you're going to increase the value of x from left to right, you are not going to have multiple values which is within the 0 value, because 0 is a single number. So anything smaller than 0 is negative, anything bigger than 0 is positive. So this is also something, this question is also something like that, that we are talking about the terminal position where the block or the cube momentarily loses its contact. Now in this case, loses its contact is essentially meaning that it is not exerting any force onto the plate, and it is free of the contact of the force. Now if it actually have to make a visible jump, then it has to have a bit more acceleration compared to that terminal value, so that we can actually observe that displacement. But we are not talking about this slightly bigger, we are talking about this exact value. So we're talking about the transition point over here. That's why we have to use the value of G is exactly this much. But if we had to observe it for a small value of gap, I mean, we have to see that there is a bit of a gap that we can see at the instance of the highest position between the block and the plate. If we have to observe that gap, then this value should be slightly bigger than 9.81. But because we are working with the terminal value, it momentarily loses contact. That's why the G has to be exactly equal to 9.81. Do I make sense?
Sir, I'm not getting the part why G is equal to A is equal to A max.
স্যার ওয়েটের ইনফ্লুয়েন্সটা বুঝতে সমস্যা হচ্ছে.
Yeah.
As the object will go upwards, it would require to produce some amount of downward acceleration from some physical source or whatsoever to make its simple harmonic motion possible. The further up it goes, the bigger should be that downward acceleration. A part of the booster, because A proportional to minus x.
G sir, G sir.
This block on its own has its weight available to itself. So as we just, for example, let's say at this position, if you consider for the equilibrium position, at the equilibrium position, the required acceleration to maintain SHM is 0, because when x equals to 0, A is also 0. So at this position, so let me give this idea into much detailed form. Let's say at over here, the block is going to exert exactly its weight onto the plate, and the plate is also going to exert exactly equal amount of upward force onto the block. So it has a 0 resultant force situation. If you wonder why 0 resultant force, because by logic at this point our acceleration is supposed to be 0. Acceleration being 0 means what? Acceleration being 0 means resultant force is also 0. So all the forces working on this block should counteract each other. So the block pushes the plate by its weight. The plate also pushes the block upwards because of reaction force by the equal value. So you have 0 resultant force over here. But for any of the upper position, Whether it's moving upwards or downward, that really doesn't matter. For any of the upper position, you have to have a certain amount of downward acceleration that has to be provided from the object to maintain its SHM. So the object needs to have a downward force used up to maintain the SHM. That downward force would come from a fraction of the weight that it is available. I'm using numerical value. Let's say, let me give you some better example. Let's say over here, the weight of the object is, let's say 9.81 না ধরে মনে করো এই পজিশনে অবজেক্টের weight হচ্ছে perfectly 100 Newton. So let's say the weight of the object is 100 Newton. This 100 Newton would be 100 Newton everywhere. At this position, the block pushes the plate by 100 Newton. Plate is also pushing it upwards by 100 Newton. Let's say when the block would be somewhere over here, then the block, then let's say the cube requires certain amount of force to maintain its SHM. Dhoro, let's say at this level, when this center setup would be over here, not at the exact highest point. Let's say at this point, the required acceleration to maintain SHM is, let's say, 20 Newton. So you need 20 Newton of force onto this object working towards the equilibrium to maintain the equilibrium. So at this point, this block, I mean, let me just copy this because it might be a bit easier for you to visualize. The figure is already becoming pretty clumsy, but so let's say when the block is over here. So at this point, this block is going to use 20 Newton of its available force to maintain the simple harmonic motion. So out of this 100 Newton of available force that it has due to gravity, it's going to use up 20 Newton at this location to maintain the SHM. So how much force would be left to it? 80 Newton. At this point, this block is going to push down onto the plate by a force of 80 Newton. That's what I want you to get in your head. So the reaction force will also be 80 Newton. As the object goes further and further, if you consider the position of the object further and further above, this force value is going to slowly become bigger and bigger, because like I said, that MA equals to M omega square X. M is the basically the mass of the
আপনার কথাটা না একটু মানে লো ভলিউমে আসছে, একটু কি ভলিউমটা চেঞ্জ করা যায় না?
কি রকম? আমি তো আমার রেগুলার সেটআপে কথা বলতেছি. The microphone is also very much very close to my mouth and I'm pretty much talking at my regular volume.
আপনার ভলিউম ঠিকই আসছে স্যার. I think it's the problem with his.
তুমি কি পিসিতে নাকি মোবাইলে?
হ্যাঁ স্যার, এমনিতে আমি পিসিতে. আমার নিজের হেডফোনে একটু মনে ডিস্টার্ব দিচ্ছে, আমি আসলে শিওর না. আপনার
try to do this. Have a look. Right click on the volume icon, open sound settings, go to the sound control panel, and then find out the output device. Here you should see your microphone or whatever that blinks. Select that one and go properties and do this loudness equalization. You have put a tick mark over here. This would give you a bit amplified sound. Might help you. So when the object was somewhere at the mid level, which is an arbitrary level, it is not essentially equal. So let's say if for this position the object requires 20 Newton of force to maintain its simple harmonic motion. আমি arrowটা ভুল লিখছি actually. এই arrowটা downwards হবে. So let's say the object requires 20 Newton of force downwards to maintain its SHM. So out of this 100 Newton force, it is going to be using up 20 Newton force to maintain the SHM. So at this instant, it would have left 80 Newton of force to exert onto the plate. So it's going to exert 80 Newton force onto the plate. As you will be slowly moving it further and further up, this value of the force is slowly going to become bigger. As this amount is going to become bigger, so your resultant force available or the reaction force available would become smaller. So if I write this equation over here, I can write that reaction force equals to weight minus force due to SHM. So let's say force for SHM. Let me write out this equation and see if this makes sense. So তোমার force required to maintain SHM যত বাড়তে থাকবে, the further bigger this force become, the smaller will be the reaction force. The point where the block momentarily loses its contact with the plate would be the point when this becomes zero. Now this one becomes zero, weight and the force required for the SHM, these two values are supposed to become equal to each other. That is basically when this will happen, that the acceleration that is required for the centripetal force has to, centripetal, the acceleration required for the SHM has to become equal to the gravitational acceleration. This is the point where the cube would not exert any more force onto the plate. Did it make sense somehow?
Yes, sir.
Yes, sir.
Yes, sir.
Sir, what do you mean when you say force required for SHM?
Force required for SHM means that as the, I mean, this is basically this expression, this one.
Oh,
Because the force required to maintain SHM is not a fixed value, pretty much like circular motion, because the acceleration is highly dependent on the value of the displacement. So further you go away from the equilibrium position, the more force it would be required for the object to maintain the SHM. Any questions so far? Anyone else? I wanted to physically explain what is happening over here, so that's why I brought about all of these different components over here. But solving that problem that from where we actually came over here, that is actually pretty simple. To be able to solve this problem, which is this one, calculate the amplitude of this oscillation. For this part of the question, you simply have to write one simple Cauchy equation, and that will be good enough. Who should be, if I just paste it over here, let's take it up over here. So calculate the amplitude of this oscillation. That can be very easily found by this expression. G equals to A max equals to minus omega square x. You can get rid of the minus because we are talking about the magnitudes mostly. So, or if you write minus, you can write minus over here as well. So what I can write, G equals to A max equals to minus omega square A. You can keep the minus over here because that is a part, this was meant to be A max. So this is supposed to be our value. So if you place the G, if you place the A value over here as a positive number, if A is placed as a positive number, let's say at the top position, then the value of G should be placed as a minus 9.81. So ultimately your minus will be taken care of. So you don't have to bother about this. So let's say minus 9.81 equals to omega square into A. So this is our variable. So you can calculate out this value of A over here because the omega was pre-known from this equation. করে দেখো কত আসে।
আচ্ছা স্যার
বলো
স্যার ম্যাক্সিমাম পজিশনে কি রিঅ্যাকশন ফোর্স 0 হবে?
At the highest position, yes, not at the lowest position.
আচ্ছা স্যার, মানে লোয়েস্ট পজিশনে তো রিঅ্যাকশন ফোর্স ম্যাক্সিমাম হওয়ার কথা।
Yes, definitely.
Yes.
স্যার ম্যাক্সিমাম পজিশনে আমাদের আসলে মানে অ্যামপ্লিটিউড যখন ম্যাক্সিমাম স্যার।
Yes.
না না।
Yes, exactly.
অ্যামপ্লিটিউড ম্যাক্সিমাম যখন তখন কি কন্টাক্ট লুজ করতেছে? Or
well, whenever you say amplitude maximum, it would mean that you shouldn't say amplitude maximum. You should say displacement maximum. Try to think of it. Choose your wording.
So at maximum displacement, the block is basically losing contact from the plate, right?
Yes, yes, because the radiation force is becoming 0. It's very important that Shubhro just pointed out a very important bit. What I must warn you that whenever you're trying to write descriptive questions for SHM part, always be very careful to choose your words. You cannot alternately use displacement and amplitude in any question. They are not the same thing. Amplitude means the maximum displacement of a particle. This means exclusively to a specific position of the entire motion. Whereas the displacement essentially remain the variable value of distance of the object from the equilibrium position at any other position of the motion. So displacement is a continuous variable, whereas amplitudes are two specific numbers. So you cannot use these terms replaceably into your description. So be very careful when you're writing your descriptive answers to write, are you trying to mean displacement or are you trying to mean amplitude? Be very careful about these two words. There are quite a good number of there are quite a good number of examiners report where they have highlighted this aspect that students messed up the wording of amplitude and displacement and they lost mark for this. So if you go through the whole examiner's report, Marx's examiner's report, you're gonna discover this information on your own as well. Just because I remembered it right now, that's why I shared it with you. Yes, Farin, go ahead.
Sir, lowest position এ গেলে কি হবে, like lowest maximum position এ গেলে?
আচ্ছা, সেটা বলতেছি।
We talked about the highest maximum position, right?
হ্যাঁ, বলতেছি। Whenever the object is going to slowly go further down, then the required centripetal force should be working upwards. So in that case, I can write that centripetal, so I can write the resultant force required should be working upwards, which should become as a resultant of reaction force minus weight. If you wonder why reaction force minus weight, because when the object is going to go downwards, then the upward force should be the bigger one, because the resultant force has to be always upwards. So the upward force on the cube is only available from the reaction force of the plate. So this is supposed to be the bigger force, and the weight is supposed to be the smaller force. So in any case, as the object slowly goes further and further down from its equilibrium position, the reaction force has to become larger, because weight is a fixed value. If this thing has to slowly become bigger and bigger and bigger and bigger, your reaction force has to also become bigger and bigger and bigger and bigger and bigger and bigger. So that the subtraction of these two numbers accommodate for the resultant force required for the simple harmonic motion to be continued.
মানে স্যার acceleration বাড়তে so resultant force ও বাড়বে, তাই না?
বুঝতে পেঁচা দিয়ে যাও। এক মিনিট। হ্যাঁ, বলো।
মানে resultant force মানে accelerationটা বাড়তেছে, so resultant force ও বাড়বে, তাই না?
Yes.
নিচে গেলে, যত নিচে যাব।
Yes.
Thank you, sir.
ধরে কথা বলি। বুঝে গেছে কি সবাই? বাকি সবাইকে যে কেন নিচে গেলে কেন আমাদের জাম্প
স্যার ম্যাক্সিমাম ডিসপ্লেসমেন্টে কি এখানে লিস্ট অ্যাক্সেলারেশন, তাই না?
আচ্ছা, from where are you asking, from which logic are you using to ask me this question? Think about it.
আচ্ছা, আমি তো উল্টা বলতেছি। এক্স্যাক্টলি হঠাৎ করে উল্টা বলছি।
ঠিক আছে, বুঝে গেছে কিনা?
হ্যাঁ স্যার, ঠিক আছে।
Okay, beautiful. So I'm moving on from this question. I think this is well explained. This was a good question for idea generation. I mean, in all cases, you have to remember this idea. I mean, as long as you're working with forces and other stuff, so you have to understand this thing, that if an object is under some sort of movement, it will use all of its available forces onto it, that is available to itself, to primarily make up for its resultant force. Resultant force make up করার পর বাকি যতটুকু থাকবে সেটুকু সে অন্য কোথাও ইউজ করতে পারবে। Or in other words, I can say all of the available forces will make up to give you the resultant force. For example, when it is going for any position that this thing is above this position, the resultant sum of the reaction force and the weight should give you the resultant force should come from the sum of reaction force plus weight, equally applicable for at the downward position as well. So the two forces available on this block, one is the weight and the one is the reaction of the plate. These two will sum up, merge up to give you the required resultant force, which is the simple harmonic motion required motion force at every position of its motion. So that's something that you need to get in your head. The better you can process this, easier your force understanding would become. Moving on, number 28, কোনো problem?
Yes, sir. B1 and C.
So we have a ball moving left and right. We have a given plotted graph of acceleration versus x. So from this plotted graph, we can essentially find out the maximum acceleration. We can find out the amplitude. So finding out omega should not be difficult. Why B1 is a problem? Maximum displacement on one side is your amplitude. So this should be 2.8 centimeter. Have a look.
ও আচ্ছা স্যার, তখন এই গ্রাফটা বুঝতাম না। হ্যাঁ,
আচ্ছা, আর ফ্রিকোয়েন্সি বের করার জন্য যেটা করতে হয়, ফ্রিকোয়েন্সি বের করার জন্য ক্যালকুলেশন করা লাগবে, সেটা হচ্ছে a max equals to omega a, or you can write a max equals to minus omega square a, omega a na, ভুল বলছি, a max equals to minus omega square a. So you're gonna place these two values from this equation, plus minus মিলায়, so ultimately ওখান থেকে তোমার omega চলে আসবে। এটা বুঝছো তো?
হ্যাঁ স্যার।
আচ্ছা, সি নাম্বারটা খেয়াল করে, সিতে বলছে the arrangement in figure 4.1 is now rotated to 90 degree so that AB is vertical. So that's one reason why the oscillations may no longer be simple harmonic. Okay, whenever this setup will be rotated to vertical position, in that case the equilibrium position Let me copy this. All right. So one of the key part that I need to understand that whenever we'll do this, then this lower spring is gonna be far too compressed, and the upper spring is gonna be more extended. So I might as well change this figure for your understanding like this. So disregard the labeling. This is gonna happen for the equilibrium position. See if it makes sense. Your equilibrium position would not give equal force available from both the objects. At the equilibrium position, your top spring is gonna be slightly more extended, and your lower spring would be less extended or might as well be compressed, depending on the question. What does the question say? So ball is held between two
স্যার
points.
এইটা কি ওয়েটের কারণে হচ্ছে?
হ্যাঁ, ওয়েটের কারণে হচ্ছে। So because this is gonna be the case, so you can see that here the weight is already a force that is available to us, and now we're gonna make it move. So why this oscillation should not be a simple harmonic? Come to think of it.
So simple harmonic কি একটা সিঙ্গেল
I forgot the answer for this question, so I might as well look for the examiner's report. So I'm doing a bit of cheating over here. Bolo.
Wouldn't the weight act as a damping force in this case?
I wouldn't say so, because whenever we have kept it in the horizontal in the horizontal surface, in that case we can talk about a friction between the contact location of the ball and the frame. But whenever we make it vertical, that contact is basically loose. So why should weight become a damping force? And even if it is damping, even if an oscillation is damped, it does not become non-simple harmonic. Very important for you to understand. Even when its SHM becomes damped oscillation, it still remains simple harmonic motion. A damped oscillation is very much simple harmonic motion. Under damped, to be more exact, because critical damping and over damping are just stopped almost immediately. So that doesn't count as continuous oscillation. It's question number 28. Should be very well at the bottom side. Lower spring may not be extended. Upper spring may exceed the limit of proportionality or elastic limit. Acha. I would not appreciate the top information, but I understand the point of the bottom line. This one makes good sense to me. The lower string may not be extended anymore. So what they are meaning that whenever the setup was horizontal, so let me just take this bit closer. So when the setup was horizontal, then both of the springs were at some extended state, as the question said, that by means of two stretch spring. Whenever we're going to make it vertical, then it is possible that the lower spring might become compressed, or it might not be at its original level. But to be honest, as far as my experience goes with simple harmonic motion, that this spring, being a spring, whether it is compressed or elongated, should still be able to provide the necessary forces to maintain SHM. That is still supposed to happen. So that point that I'm not very much relying upon, but they have given the answer in examples, so we can have a lot of different variable answers over here. I personally like the second option better, that the upper string may exceed the limit of proportionality because it's going to be under a lot of force. That one makes good sense to me. Have a look at the examination report. There are very few candidates who had any real appreciation of this question. In nearly all answers, it was thought that the weight of the ball would either prevent simple harmonic oscillations or cause heavy damping. Any effect of the extension of the springs was not considered. You see, makes sense. I'd go for the second option. That one looks lucrative and credible, understandable to me.
স্যার
Yes.
ওয়েটের ইনফ্লুয়েন্সটাকে একটু বুঝাবেন, মানে ওয়েটটা তো এখানে নরমাল কন্টাক্ট লুজ করে, সো ওয়েট হচ্ছে গিয়ে এখন আর ব্যালেন্সড হচ্ছে না কোনোভাবে, তো ওইটার কারণে কি হচ্ছে?
ওয়েট অলরেডি ব্যালেন্স হতে পারবে কিভাবে আমি তোমাকে বলি। মনে করো হচ্ছে আমি তোমাকে কিছু নিউমেরিক্যাল ভ্যালু দেই which might make sense to you. We are not given the exact value of the extension of the springs. So let's say whenever it was in horizontal case, let's say the extension of each of the springs over here were, let's say, 5 centimeter each, both for both the springs. We do not know the original length, but let's assume the extensions are 5 centimeter each. Whenever you're going to place it vertically, it is possible that this thing is going to have a much bigger extension because now we have to support the weight of the spring, right? So it is possible that this might as well become, let's say, 8 centimeter. So which means that this has gone down to this part, and this part might as well become 2 centimeter. So I'm assuming that compared to this position, this ball position has moved to the left, or from this position, the ball position has moved to the down by a value of 3 centimeter, let's say, to balance the weight. So it is possible that this kind of situation will happen. So both of the springs would not be behaving identically over here. The problem that we might come across, if the mass of the ball is extremely large, which is not a factor over here because they're only pushing it left and right, so weight is not being balanced by any of the springs. But here, the top spring has to sustain the weight of the ball. It has to. The lower spring can also provide a certain amount of upward force if the lower spring become compressed. But as long as the lower spring is not compressed, for example, for the values that I have given, that it is still now at a extension state where the extension value is, let's say, 2 centimeter. So the lower spring is pulling the ball downwards. The weight is also pulling the ball downwards. Both of these downward forces are to be balanced by the top spring exclusively. So it is possible that this spring might go across its elastic limit. Now, if it goes across this elastic limit, you are not going to have simple harmonic motion because in that case, the forces are not going to be same as your oscillation goes forward. Because if you remember the graph for the FS graph for the elastic behavior, the simple idea that it goes further from your AS level, that let's say this is the elastic limit or the proportionality limit. The spring got this much extended on the first extension of the oscillation. Then it is going to come back along this line, and then it's going to be providing you this much force. And then if you start to do the second oscillation, then it's going to go up along this line, and it's going to have once again a bit more permanent deformation because the force is extremely large. So for every single oscillation, this is going to become more and more permanently deformed. So you are not going to have equal forces available from the system.
Sir, but আপনি না বললেন যে extended
hold up শুভ্র, মিথিলা বুঝছো কি বলছে?
হ্যাঁ স্যার।
আচ্ছা, কোন কোশ্চেন?
স্যার আমি বলছিলাম যে
মিথিলা তো কোন কোশ্চেন?
আচ্ছা না স্যার।
আচ্ছা ঠিক আছে, হ্যাঁ শুভ্র বলো।
আমি বলছিলাম যে নিচের স্প্রিংটা স্যার আপনি না বললেন যে এক্সটেন্ডেড মে নট বি এক্সটেন্ডেড লেখা মার্কসিমে, তাহলে এখানে যে আবার বলছেন এক্সটেন্ডেড হইতেও পারে।
May doesn't mean it is definite. May means it might not be extended. For example, I have assumed that this falling level was 3 centimeter. I could as well consider this one to be 5 centimeter. In that case, the extension of this top one can become 10, this one can become 0. Or if you consider this, হ্যাঁ এটা compressed হতে পারে, extension থাকতে পারে, 0 level থাকতে পারে. You cannot say exactly what is going to happen over here, but you can definitely say this one would be highly extended. That is definitely a sure information. That's why I prefer the lower one. বলো।
কিন্তু মার্ক স্কিমে কেন তাইলে বললো না যে এখানে কম্প্রেশনের পসিবিলিটি আছে?
That's why they wrote the word it may not be extended. May not be extended means it might be at its original length, it might be compressed. May not be extended means it could be anything. Think about it. May not.
Okay.
বলতে পারি না যে all the possible forces will be used to cancel out weight, so none will remain for simple harmonic motion.
আচ্ছা মিস্টার তোমার কোশ্চেনটা পড়ে নিচ্ছি। শুভ্র বলো, শুভ্র কি বলতেছিলা? কোশ্চেন শেষ করো, একজন করে আনসার করি। শুভ্র বলো।
আমি আসলে স্যার বলতে চাচ্ছিলাম যে মানে আমরা যদি লিখতাম যে the spring may be compressed or something, এরকম কিছু কি অ্যাকসেপ্ট করতে আসলে
করতো
করতে
because the question is given in terms of the examples, so there is not a stipulated specific sentence that you might have to write, but you would have to say which one. The whole in the mark scheme they have underlined two words, lower and upper. Which spring are you talking about? You have to specify that. So if you did write that the lower spring might be under compression and the SHM might not happen, you would also score the mark. That is a similar word for the first sentence.
Okay, sir.
হ্যাঁ মিথিলা কি বলছিল?
আমরা কি এটা লিখতে পারি যে all the possible forces are used up to balance weight, so none remain for simple harmonic motion?
No, that's not essentially true, because we have hanged the entire setup not with a rigid support. We have hanged it using springs, so you can have a variable amount of force from the setup of the hanging mechanism. If you did hang it with a solid setup like a rod and bar, not in that case that might be a problem, might be a situation where the components do not have any elastic behavior or expandable behavior, but here that's not the case, so you cannot say that.
আচ্ছা স্যার।
Moving on. Yes,
স্যার এখানে তো আপনি বলতেছেন এখানে মার্কস কি মনে বলতেছে যে আপার মানে আপার যে স্প্রিংটা আছে এই স্প্রিংটার লিমিট অফ প্রপোর্শনালিটি এক্সিড করে গেলে ও পার্মানেন্ট ডিফর্মেশন মানে আরো বেড়ে যেতেই থাকে যদি অসিলেশন চলতে থাকে, তাই না? তার মানে কি এটাই বোঝাচ্ছে যে মোশনটা লিনিয়ার হচ্ছে না?
yes, মোশনটা তোমার ওই a proportional to excessive behavior এই বিহেভিয়ারটা সাস্টেইন করবে না।
আচ্ছা আচ্ছা আচ্ছা।
মানে simple harmonic motion the defining property for the simple harmonic motion that a proportional to minus x, that would not be followed throughout the motion, so which essentially makes it non-SHM. Sure. Moving on, the last question, that is, I think, no, not the last, maybe not the last. Okay, 29 কোন problem, anything from 29?
Yes sir.
29 problem আছে স্যার, A3 হ্যাঁ A3
and C.
Question দেখে যাবো প্রথম থেকে। A small frictionless trolley is attached to a fixed point of A by means of a spring. A second spring is used to attach the trolley to a variable frequency oscillator as shown in figure of 2.1. Both springs remain extended within the limit of proportionality. Beautiful. This is a very important information for the setup to work. Initially, the oscillator is switched off. The trolley is displaced horizontally along the joining of the two springs and then is released. The variational time t of the velocity of the trolley is shown in figure 2.2. So this is the oscillation of the trolley without the effect of the variable frequency oscillator. So this is its natural frequency. Initially, the oscillator is switched off. So we just moved it a little bit and it was oscillating like this. So this is the natural frequency. So initially it has zero velocity and it's going up and down like that. Using the 2.2, using figure 2.2, state two different times at which the displacement of the trolley is zero. Displacement of the trolley would be zero when the velocity is maximum. So find out any of the positions on this entire graph where velocity is maximum, either in positive or in negative direction. This might happen for 0.1 second, or it won't happen for 0.3 second, 0.5 second. Any of the peak values or the trough values you can choose, and you can write those two time frames. The acceleration is in one direction is maximum. Acceleration maximum হয় কখন? Velocity যখন 0 হয় at one of its terminal position, which means when you, so you can choose any of the points on this graph where velocity is labeled to be 0. So you can choose 0, you can choose 0.2, you can write 0.4, 0.6, 0.8, 1.0, any of these 6 values are acceptable. So you have to understand the idea that how this VT graph would I mean, basically what they are asking you to understand, that can you interpret the VT graph into distortion and acceleration information. So that's what they're checking over here. And both of these numbers have to be absolutely correct to score this 1 mark. This 1 mark is a what can I say? It's a total. It's a both mark for both of these answers. Any of this wrong, you shouldn't be scoring this 1 mark. আচ্ছা, ক্লাস যখন শুরু করছিলাম, the number of students used to be 680, somewhere around 80. Now the student number decreased for the up to the last question I see of 74, and now it has become 61. What happens to the rest of the people?
They just die. So
I think they got lost in the internet. They converted their consciousness into virtual and got lost in the junk of the data of internet, maybe.
স্যার
C3.
A3 টা
হ্যাঁ, এটি 2000 যেমন frequency of the oscillation of the trolley, that's pretty simple. You have a look at the graph, find out the time period, and omega equals to 2 pi by t. See, they will say the variation with time of the displacement of the trolley is sinusoidal. Sinusoidal means the graph looks like a sine curve. A cos curve is a sinusoidal curve. A sine curve is a sinusoidal curve. A minus sine curve is a sinusoidal curve. A minus cos curve is also a sinusoidal curve. So that shape of continuous variation up and down, that shape is called sinusoidal. Sinusoidal doesn't necessarily mean sine curve exactly. Sinusoidal means the variation is behavior is like sine curve. So state the phase difference between the distortion and the velocity. 90. It is how much? 90 degree.
স্যার এটার মানে কিছুই বুঝতে পারলাম না কোশ্চেনের A3 টার।
বুঝাচ্ছি আমি। I'll help you understand. Don't worry. Have a look. This is a VT graph, right? If I want to convert this into distortion time graph, how this graph is gonna look like? I'm gonna draw that thing onto this exact portion. So come to think of it, if you have a sine curve, just normally তুমি চিন্তা করো, আমি normally basic concept বলি তারপর আমি further drawing করে দেব. Let's say if you have a sine curve, if you integrate this, what you're gonna get? Cos or minus cos?
Cos.
স্যার cos।
Sine কে integrate করলে cos হয় না, minus cos হয়।
Sin কে করলে cos হয়, cos কে করলে minus।
কেমনে? cos কে ডিফারেন্সিয়েট করলে হয় হচ্ছে minus
ইন্টিগ্রেশন
cos কে ডিফারেন্সিয়েট করলে হয় minus sin।
হ্যাঁ।
So sin কে ইন্টিগ্রেট করলে হবে হচ্ছে minus cos।
জি। But sin কে differentiate করলে cos হবে।
Exactly. So I'm velocity থেকে আমি ডিসপ্লেসমেন্টে যেতে যাচ্ছি। So I need to integrate the sine curve. So integrate করলে কি আসবে? Minus cos আসবে, ঠিক আছে?
জি।
Minus cos কার্ভ হওয়ার মানে হচ্ছে if I
আচ্ছা এইভাবে দেখলে বোঝা যায়।
হ্যাঁ, এভাবেই দেখতে হয়। Minus cos কার্ভ হওয়ার বেসিক মিনিংটা হচ্ছে something like this.
লিডিং কত ল্যাগিং কত ওটার
Exactly. আমি এটা এখানে ভালো করে আঁকতেছি না কারণ আমার খালি হাত আঁকা difficult, but I might as well take your observation to this graph. Have a look at this graph. What is the phase difference between the V graph and the X graph? How would you say what is the phase difference?
90 degree.
That's basically your answer, but do you see it?
Yes, 90 degree.
So that's your answer. So you write 90 degree over here. Did they ask for any explanation or did they only ask for the value? Value. So 90 degree. That's it. Acha, B number parso. C the problem bosila, right? Acha. B and C are related, so I might as well read the question. Answer question number B reads: the oscillator is now switched on. The amplitude of the vibration of the oscillator is constant. The frequency f of the vibration of the oscillator is varied. Okay, we are maintaining the same amplitude, but we are increasing the frequency, varying the frequency. For example, the trolley is forced to oscillate by means of the vibration of the oscillator. The variation with f of the amplitude a naught of the oscillation of the trolley is shown in figure 2.3. This is supposed to happen because we can know this from the idea of a resonance, that as your this is the basic amplitude versus frequency graph, resonance graph. By reference to answer in A, state the approximate frequency at which the amplitude is maximum. This is the exact natural frequency of this value. So you're going to write this number. C number says the amplitude of the oscillation in B may be reduced without changing significantly the frequency at which the amplitude is maximum. So if we reduce the amplitude at a specific frequency, it is possible. State how this may be done and give a reason for your answer. You may draw on figure 2.1 if you wish, which means they are expecting a drawing. The amplitude of the oscillation. Question of bujo. I'm gonna divide this question into pieces. the amplitude of the oscillation in B may be reduced without changing significantly the frequency at which the amplitude is maximum. So we are now going to reduce the amplitude but keep the same frequency. State how this may be done and give a reason for your answer. So how could we possibly reduce the amplitude on figure 2.1? Reducing the amplitude means that you do not want your object to reach to the same amount of amplitude as earlier. So you have to somehow provide a damping force so that, or a resistive force, so that within the same amount of time, that is 1/4 of the time period, let's say from equilibrium to the most right or most left position, for within that time, the object should not be able to reach to the same displacement, maximum displacement as earlier. So you need to provide some sort of damping mechanism onto the trolley. If you apply some sort of damping mechanism, you can have that. But that damping mechanism would not essentially cause it to have under damping situation, because you have to understand, as for of option choice C, we are now making the trolley to move from an external vibration frequency oscillator. So this thing is continuously feeding energy to the system. এটা কিন্তু continuously আমাদের system energy কি করতেছে, input দিচ্ছে. So you can essentially make this trolley to have a damping mechanism, which can slightly reduce its amplitude value for the same frequency, but this will not give you a graph of under damping, because energy is continuously being fed into the system by the variable frequency oscillator. So এরকম যদি হতো যে আমরা এটাকে একবার অসিলেশন করে ছেড়ে দিছি, তখন আমাদের এই in that case these curves are going to slowly become smaller and smaller and smaller and smaller under damping case. But in this case, this will not be under damping. So basic idea, we need to introduce some sort of damping mechanism over here. There are multiple different options you can go by. One of the options is that, now try to come to think of it, you need to provide some damping force over here. What is your most likely, most preferable choice? Think to increase the damping force.
Sir, এখানে তো necessary হচ্ছে না, ঠিক না? We are just decreasing the amplitude, কিন্তু this can still continue harmonic motion at a constant amplitude, right?
Constant amplitude is supposed to exist.
So we can use friction here. We can introduce friction.
Constant amplitude is supposed to exist, but as for the equation number C, we are specifying, the question is specifying that we want to reduce the amplitude slightly without effectively changing the frequency. So this is very much similar to the idea that we do not want to change the mass of the oscillating system, if you come to think of it. Because ঠিক আছে, so
এখানে কি আন্ডার ড্যাম্পিং হচ্ছে,
তোমাকে খুব স্লাইট একটা আন্ডার ড্যাম্পিং ইন্ট্রোডিউস করতে হবে। স্লাইট একটা আন্ডার ড্যাম্পিং এরকম ভাবে ইন্ট্রোডিউস করতে হবে that so that your damping mechanism or that addition of the damping source would not affect the frequency of the system. So you have to provide referring from our earlier lectures, that you have to provide a damping mechanism that would not significantly change the mass of the system, but can provide a significant damping force. Or in other words, you have to introduce a very light damping source if you attach it to the trolley, or if you don't want to attach it to the trolley, you can have it something else. Let me give you a couple of examples, but then you can try to be creative, and then I'll take your options as well. One of the ways we can go for, so that we do not change the natural frequency of this trolley at all, is other than attaching any damping mechanism with the trolley itself, because we do not want the frequency to be affected. Because we do not want to make any change to the frequency of the setup. So attaching some object with the trolley might be our last resort, but there can be other things we can do. For example, the very simple thing that I can talk about, I can put in some sand on the path of this trolley, so that the wheels continuously have to go through that sand, and that can give us some damping force. Think about it. আমি মনে করি এই জায়গাতে এতটুকু উঁচু একটা স্যান্ডের একটা পাতলা একটা পাইল করে দিলাম, so every single time the trolley is trying to go back and forth, it is no longer a frictionless surface. It becomes a sort of frictionful surface. That can happen. So I'm not essentially attaching any mass to to my oscillating body, but I am introducing a bit of resistive force. That can be one happening. Option 2 can be I can immerse this entire setup into a oil tank, or if my setup or if my setup is leak proof, I can put it into a water tank. So that now, because now the trolley is essentially, they have asked for a little change, right? Nah, they haven't said about little change. They have only said that we do not we want to reduce the amplitude without significantly changing the frequency. So the amount of drop of the amplitude can be large. So yeah, so we can place this entire oscillating setup into inside a liquid container, for example, an oil container or a water container, which would essentially give us a much bigger resistive force. These are the two options that I can think about without changing the trolley structure. If you don't want to, if you cannot think of these options, the other options always remains is that we can attach a cardboard perpendicular to the alignment of the springs and the trolley, which has a very small mass compared to the mass of the trolley, and we attach it with few drops of glue. So what I mean is this: if you are trying to draw something over here, let's say for this part of the question, we can try to draw a cardboard that is attached over here like that. So you just draw a line over here and label this thin cardboard. And in your description, you should write the thin cardboard is attached with the trolley perpendicular to the line of its motion, and the mass of the cardboard is very small and compared to the trolley mass, and it is attached to the trolley with only a few drops of glue. So you are going to introduce a damping mechanism, but because you are already mentioning that it is very lightweight, it is not going to effectively change the mass of your oscillating system. In turn, that would not essentially change the natural frequency of the oscillating system, but your amplitude is going to be simply significantly reduced because you are now providing some damping. So these are the three options that I can make sense with. But if you have any other proposition, let's talk about them.
Sir,
hello.
Sir, আপনি যে বলেছিলেন যে আপনি like sand ঢালবেন ট্রলির মধ্যে, right?
Yes.
So ওইটা তো একটা significant mass change আসবে না ট্রলির মধ্যে, so ওইটা তো আর under damping হবে
No. I meant I would not attach sand on the trolley. I meant I am gonna pour trolley on the track, pour sand on the track. So something like
oh
this.
আচ্ছা আচ্ছা
So মনে করো আমি এই জায়গাটুকুর মধ্যে মনে করো আমি স্যান্ড দিয়ে দিলাম। So সে যতটুকুর মধ্যে মুভ করবে, every single movement back and forward, it has to move out some of the sand particles by its wheel movement. So it's going to be a bit more frictional, yeah, rough surface. Okay. That can be one of the options.
Thank you, sir.
Yeah,
we could attach a sandpaper on the stage below the trolley to increase the frictional force.
Yeah, that can also work. That might as well work. Or you can also say that we are gonna, other than sand, if it makes better sense to you, we're gonna pour some glycerin at the bottom of the wheels of the trolley, because glycerin is pretty sticky. So the wheels are not gonna be, they're gonna go through a hard time getting off of the surface of this thing. That also increases friction. You can be creative. So let's have a look at the Mars scheme and see what kind of answers that do they expect. Example: attach sheet of car to trolley, increase damping of frictional force. Example: reduce the oscillator amplitude or reduces power or energy input to the system. Okay, they didn't say anything about changing this figure. Okay, the vast majority of the answers were cut. It was generally appreciated that the oscillator ought to be damped, but there were few answers that stated how this would be done. Correct answers usually involve attaching something to the trolley that would increase the drag force on it without significant increase in the mass. Example: a sheet of cardboard. No credit was given to answers that suggested a significant change in the mass of the trolley or a change in the spring constant of the springs. So they haven't used the idea of increasing the friction of the setup altogether, neither in the examiner's report, not in the Mars scheme. But I would say this is going to work anyway, because both of the options are given in terms of example. So the third example, the option that we are discussing, that we can increase the friction of the system and essentially achieve the similar effect, that would be acceptable to you, acceptable to the examiners, because these answers are given in example and none of them are stipulated hard answers that has to be there. So you can be creative about this. Yes.
স্যার ওই রিডিউস পাওয়ার অর এনার্জি ইনপুট টু সিস্টেম এই পয়েন্টটা আমি ঠিক বুঝলাম না, কারণ কেই যদি বাড়ায় দেয় তাহলে তো টাইম পিরিয়ড বাড়বে বা সামথিং লাইক দ্যাট।
নো, নট এসেনশিয়ালি। আমাদের টোটাল এনার্জি ফর্মুলা কি ছিল? টোটাল এনার্জি ফর্মুলা ছিল হচ্ছে হাফ এম omega square a square. So if you reduce the power of this thing, you might as well be make sure that your omega square pretty much remains the same, but you're gonna move this end by a smaller amount. Let's say for a higher power, you are moving it at, let's say, 1 centimeter amplitude. Now you are moving it as at a half centimeter amplitude. So you don't, I mean, to reduce the power provided to the system, you don't necessarily have to change all of this. You can design your setup, or you can change your setup so that the omega remains constant, but the amplitude is affected when you are gonna change your power. But that part of the description has to be very clearly written in your description. বুঝতে পারছি?
আচ্ছা, হ্যাঁ।
Okay. Anyone else? Anything about this thing? বলো।
স্যার A3 টা আরেকবার একটু রিপিট করা যায়, আমি শুনতে পারিনি আসলে, হেডফোন আছে।
না, আমি পুরোটা আবার রিপিট করব না। it was a pretty long discussion. আমি একটু পরে লেকচার আপলোড করতেছি, তুমি ভিডিও থেকে দেখো। কোনো কোশ্চেন থাকলে আমাকে নক করো, I'll help you, no big deal. Because the class is pretty much over. I really want to get to the bottom of this worksheet. It's getting late. Please hold. আচ্ছা, আর কোশ্চেন বাকি আছে কয়টা? একটা বাকি আছে মনে হয়। The last question number 30. আচ্ছা, এটা তো electromagnetism case. So you might as well be able to solve all the question up till before the electromagnetism. So A is basically what you can solve for this question. Could you solve A for this one?
Yes, sir.
Okay. So that's pretty much it for the SHM lecture. So from next class, I believe we're gonna start thermal. I think thermal is the third chapter. তোমাদের কারো স্কুলে কি লেকচার শুরু হয়েছে?
Yes, sir. আমাদের স্কুলে
স্কুল শুরু হয়েছে?
জি স্যার।
স্কুলে কোন কোন চ্যাপ্টার পড়াবে এগুলো কোনো আউটলাইন দিছে নাকি জাস্ট র্যান্ডমলি পড়ানো শুরু করে দিছে?
স্যার সাইমালটেনিয়াসলি এখন একটা টিচার ধরেন পড়াচ্ছে যে সার্কুলার মোশন আর এক জায়গায় ম্যাগনেটিজম।
ম্যাগনেটিজম?
জি স্যার।
Wow. Magnetism is chapter number 5 in my sequence, as you can see over here. Acha, the lecture is over, so I might as well stop the recording and let's